You are looking at Skull 21, which belonged to a Triceratops, a dinosaur that lived 66 million years ago. It was found in the late 19th century in the United States and traded with the Delft University in the Netherlands. Now, the enormous skull of this ancient creature is being restored once more, using a combination of old and modern techniques. Scientists and craftsmen set out to restore the skull with a unique combination of cutting-edge technology and tried and tested techniques in a huge collaborative effort.
The main goal was to restore the skull with the new scientific insights, with modern techniques, and we wanted also that the public would see which parts are originals and which parts are added during the restoration.
I was super enthusiastic about this project, of course. It's one of the main goals, of course, to reconstruct it as good as possible, but also try to see the different technologies that can all together make it happen with a better result than the past.
It's so nice to have a traditional old skull to be able to reconstruct it with new technology.
Restoring the skull is a time-consuming and labor-intensive process. A combination of different techniques is used, like 3D scanning, modeling, and printing, in addition to a lot of old-fashioned manual labor.
In this giant hole, there used to be a giant eyeball like this. And what would it have looked like? What did it do? What could it see? It's all about the curiosity, yeah. We want to know everything.
Since the skull is not complete, the team starts by getting reference material of other skulls, like the one at the Paleontological Museum in Munich, where they meet Professor Raoult.
We're trying to understand the history of life on Earth. And it's like with all historical sciences, if you want to understand what's going on today, you need to understand how this happened and where that came from. Every child has this phase of loving dinosaurs. And then there are the few people who never grow up, like me, and they make it their job. So that's basically what happened.
A specialist makes a 3D scan of the skull.
The scanning looks a lot like you are painting from a little distance. You're painting across your model. Up till now, people are still just making 2D drawings. It's not as accurate and not as complete. And of course, it's not 3D.
A pattern of light is projected onto the skull. Several cameras are constantly looking at this pattern. Because they look at the object from different angles, a three-dimensional shape can be derived, just like our own eyes see depth.
In the past, of course, they did not have access to all these technologies, and they had to do it based on so many assumptions and measurements that were not accurate. But now, luckily, we have all the means to actually accurately really achieve results that we want for this.
The team manages to scan, model, and print the skull with a precision of 0.3 millimeters. While Javid is working on a 3D model of the skull, Art is cleaning up all the different parts. The first step is to remove old sediment and plaster. Seeing the difference between fossilized sediments, plaster, and bones is a very specialist job, where Art's craft is particularly important. While cleaning the skull, he discovers that the dinosaur's teeth are still mostly intact.
They didn't prepare it out. There was still soil on top. And I've tried to remove it, and I'm finding 1 tooth, 3 tooths, whole batteries of tooths.
Since the skull has spent 66 million years in the ground, it has been deformed by geological processes.
This skull has been pushed by the weight of the earth. I will try to get parts separated and glue them back in the right angle, because now it's like a broken bone. First you break it and then you make it. So first I demolish, take all the parts off, clean it, break it, and then I start gluing, modeling, and putting it together again. It's like a puzzle. I'm lucky. I can see how the puzzle should be. This is a scan from the skull in Munich. In Munich is an example of a nice skull. We use it as our, so to say, ideal skull.
Because of weathering or wind, water action, the skull broke up in many pieces. Some parts are missing. So what we did is made a digital reconstruction and translated that in files for 3D printing to print an entire skull.
Before you can print, the 3D model needs to be completed using the reference scans from comparable skulls. That's where Javid comes in.
I had to do my homework in a way to catch up with all these different ways of describing the anatomy of the skull, learn all the different bones and the parts. It has a very complicated nature because it's something very organic.
A lot of back and forth between the experts was needed to get the model just right.
It's a very iterative process.
However, it's not the first time this skull has been restored.
The Skull 21 was found in Wyoming in 1891. It was transported to the Peabody Museum in New Haven, and there it stayed for more than 50 years in a storage facility. Skull 21 was exchanged with Delft, and it was then the first time that Skull 21 was restored. But when it was transported, an accident happened and the skull was damaged and it had to be restored for a second time.
Dr. Krausinger, a retired curator, took it upon himself to restore the skull to the best of his abilities.
You know, it was the 50s, man. There was no Googling your Triceratops back then, so you just had to make do with some figures from some scientific journals and stuff like that. He did the best he could, and I think we should be very grateful for what he did in actually saving the specimen. To honor his work, we should give it the extra push and use techniques from nowadays and the insights from nowadays to make a more lifelike specimen from this beautiful skull.
Because the target of the restoration is to make the skull as lifelike as possible, Javid has to do a lot of complicated analysis.
You cannot, for example, say, hey, I want to take part of this and put it in our skull. I had to run an analysis, putting some anchor points as references on the Munich skull and measure the distances and the angles, so I could extract aspect ratio of the skull in 3D. I applied the same reference points on the Delft skull. Now I understand how the points need to be displaced in order to project a more realistic shape of the frail.
The combination of new and old techniques is excellent. If I would take a right horn and I would say I would need a left horn because they didn't find it, for me it can take a week to model a left horn. With the computer you say mirror and it makes another one.
After this iterative process, the missing parts are ready to be printed.
3D printing allows to almost produce everything that you want. You just have to model something and then send it to the machine, and then it gives you what exactly you were trying to achieve.
Due to the enormous size of the skull, this was a challenge on its own.
We found this company that can print like parts 80 centimeters in height in one go.
Printing large pieces at once saves the team the effort of gluing hundreds of little pieces together.
After a couple of weeks, we hear back from them that your part is ready and we can pick it up. And then we just have to glue back all those like big chunk of 3D printed bones.
First, a test print is made to see how the 3D printed parts fit together with the original bones. This is a crucial step in the research-based process because the team can see how it comes together in real life. Using the test print, Art also makes a steel frame to display the skull. Once the final prints arrive, the final assembly can begin.
We tell the story about one individual and about how we went about in the restoration process. People get insight what we did and why. We don't know everything about the skull. The more research will be done, the more we know about the Triceratops. This is the result of we think how the Triceratops looks like.
And so, the story of Skull 21 continues. Hopefully, it inspires a whole new generation of scientists and artists.